Excuse me.
Make sure that you and your neighbor are getting similar answers for each one of these as you go.
No.
Yeah, no, that's right.
We don't want a lot.
The last, yeah. Yeah. We're just comparing them if it is not about 30. If that's true. It's true.
Page 13.
Oh,
Page 13, yeah.
I like that idea. I like that. I guess you would say more lane, but it's say. Page 9.
That is not it.
Um,
My bad.
oh,
Page 9 should make a lot more sense.
I'd like to see
You could do page 13 later.
If we're body, there's no body. There's no horizontal. Oh, yeah. This was.
Yeah.
It's not for my time, it is not.
This one.
This is a top. Yeah. So you also need to. I like where you're.
Oh, yeah.
Exactly. You do so bad.
Emotion wise.
Kids.
And then like you can do this one, and I can only do it on and off. Yeah.
Oh, yeah. How heavy does this fit? It doesn't, why doesn't it exist? Sorry, can you? Is it enough to think what's top heavy?
If it's top heavy, there's no equal. Wait, if it's top heavy, then it's oblique. Yeah, it's oblique, so we have to determine like the slant and the oblique. I mean, it doesn't say.
So it's like for the explanation, if it say that it's top heavy or it's not.
No, I was talking about like.
What do you think of a rational?
Wait, if it's oblique,
Yeah.
it's still exists, right? It still exists, it's not horizontal.
But that's the one, like the asymptotes that are. No, that's.
Now, this is one, that means in the middle, have inches high.
Is it like? Wait, is that what you do the division? No, that's, they have the same degree. So it works, so I say just like, oh.
That means.
How'd you do it? How'd you like?
Yeah, right. You don't even tell one of you. When I thought I tried out. But I lost it. Like I thought, like Brad's like. Like we
If I could just play.
Okay, and then what? Oh,
How do you do that? It's so good.
I just. So. I feel like we're going through you. I wonder how it tastes if you're not.
Wait,
I don't know
wait, are we actually?
Wait, take another minute or so.
Alright.
It's like when you do like, it's like the first coefficient, whatever you want to call it, like formula.
Oh, when you find
It's like the, you don't matter, you don't get enough of a different. I think they're.
It's 25. It's 25. I think. Why goes to.
Oh.
We're talking about why two separate, but
We're not doing.
we do it.
Like if you.
How do we?
This is the limit, so it can be
Oh,
like that.
yeah.
On degrees and it's,
Yeah, why, this is the, that's my fault.
About ready?
Can you give us?
Yes.
This is bottom part, so.
Yeah.
The graph.
Now I realize that I feel like X, you're like grounding, okay, I was close. That's like max. Just like you.
Oh.
Ground is like all.
Why? We have.
No, you can so.
Yeah, it's. And you like maybe think about it, and that and we also.
Yeah. So, limit of faith in.
English is like.
That's the max. What max equals.
Yeah.
Entity.
10 seconds.
Right there, man.
Wait, but it's the same end.
Okay, folks, let's talk about this warm up. Finished or not? We'll just finish it together. So don't worry about it. I hope that you got through 1A. Was this a difficult problem? Okay, good. I'm proud of you. I'm proud of you both. It looked like you picked up what each other put down.
Yeah.
Well done. Okay. Would you please show me your answer for A? Show me your answer for A, please. Show me your answer for A. Good. You didn't use a calculator for that, did you? Right. It's just two. Right. It's just 4 times 3 divided by 6, right? Is that what you did? Right. It's approximated without a calculator. I hope you didn't do this. If you find yourself doing this kind of thing in my class, you're probably not picking up what I'm putting down. Right? You shouldn't have to do detailed work like that. I'm normally looking for just kind of idea. So 4 times 3 divided by 6, yeah, it's 2. For B, oh, look what I have here. Oh, oh my gosh, a cup full of happiness. So it's our first time doing these today. So yeah, you've had a chance to discuss. I just want to know what you discussed. I just want to know your thoughts on 1B.
You can get 5 pounds.
Oh, thank you. That's very kind of you. Let's see if I did. It's up to Destiny. It's Kayla. Kayla, can you tell us about 1B? What'd you do with this? Okay. Okay. Okay, and you got negative 200,000, like that, is that right? Is this right? Did you get this? Any questions? Nice. So I like how you turn this into like a, you actually have the meaning of this number one, 10,000, he says, just multiply by 10,000. Of course, there are tricks, so if you have a decimal here, you just kind of move it over until there's no more decimal in the denominator. That works. Thank you, fantastic. First one. Please do. Now, if I were to add like a nine, another nine here, would that change the answer much?
No.
Or if I added another zero here, would that change the answer much? If I put another zero in here, would that change the answer much?
Yes,
If I put another couple zeros in here,
that would change it a lot.
that would quite change it, would it?
Yeah.
Okay, so when you're dividing by little numbers, that kind of changes things. So keep that in mind for later. Okay, two was an interesting one. I didn't ask you to find f of 4.01 or f of 3.99, but compare them. I'd like to see what you got. Miley, do you have a chance to talk about this one? Do we agree with that? Even though two different x values, they're the same? And how did you know that? So this one is 0.01 squared, and this one is negative 0.1 squared. So, and we could do the work. That's not difficult, but you can see quite clearly that they're the same. Are we okay with that? Think about it. How can we think about this visually speaking? Yeah, Max.
Okay, so you plug in 4,
Uh,
no, that's a 0.
okay.
And parabolas at the zeros will be like symmetrical about their kind of like x-axes. So we know 4 is the x-axis. And 4.01 and 3.99 are like equidistant from the intercept. So we know that therefore they are like the same height.
What do y'all think? Does that make sense? And when you said x-axis, I think you mean axis of symmetry. Is that what you meant?
Yeah.
The axis of symmetry. Yeah. Yeah, so they're equidistant from the axis of symmetry. So yeah, since it's a parabola, it has that symmetry that you talked about nicely. So yeah, those values will be the same. Okay, just checking in with a few things. Let's go to the packet. Page 3, for page 9. Numbers, they're tough. Okay, this one. Find the horizontal asymptote of each. Well, let's do this together. Does this one have a horizontal asymptote?
No. Wait, yes. What am I talking?
Today's opposite day, obviously.
Today's Friday.
Yes, obviously. Okay, so it has an asymptote, and would you please show me the number associated with that horizontal asymptote? It is 0. Who could explain to us how we know it's 0? Yes, Jonas. This is a bottom-heavy rational function, so it's always going to have a horizontal asymptote y equals 0. Are we okay with that? When we say bottom-heavy, we're talking about the degree of comparing the two. Okay, so B, I'm gonna ask for some help. Well, what do you think? Does it have a horizontal asymptote? Yes or no? You can thumb, everybody. What do you think? No. Boo. How do you know it doesn't? It's top heavy. Okay, so no, it's top heavy. Okay, so the only other case would be, see what you did? There is no middle heavy. Yeah, if it's equal degree. Okay. Which takes us to number 2. I'd like to see what Nia, did you get an equation for this one? Okay. Okay,
So 1/x minus 0.4 over 5.
oh, okay, okay. So like we could think of this as 1/x minus 4/5. Okay, and that's a horizontal asymptote because,
Um, Like where the graph is kind of leading
okay,
showing that.
to this number here. Okay. Um, okay, interesting. Thank you. Yeah. Do you have some input there, Ryan? I'm giving, excuse me.
Since the horizontal axis is 4 over 5, you can make those the leading coefficients, so the numerator and denominator. So I did for example, 4x cubed over 5x cubed. Because that it has to be middle heavy. Because when it's middle heavy, the horizontal axis. There.
I know you're on my list.
I think it's a good term.
It is a pretty good term. It's my good list.
It's good, this.
Yeah, my good list. Okay, so what do we think about this one? Are we okay with that? I want a little something more. A little bit more. Spice it up. Connie, you know what I'm talking about?
Me and Max added more numbers to it.
Oh.
4x squared minus 3x plus 4 and then 5x.
I'm gonna do this over here. So what's it they added on the bottom? 4x minus 3. Does it really matter what's there? It doesn't matter what's there. All we care about is the
The leading coefficient.
leading coefficients. Yeah, so Nia, you got that 4/5 in there, but it was that's doing a different thing there. But that we are going to be talking about that today. So it's a little bit of a foreshadowing. So and how many different possible answers are there here? There's an infinite number, as long as the ratio of those leading coefficients are 4 to 5. The thing I don't like about this is that this is actually 4/5. That's not a horizontal asymptote. That is a horizontal line. So I'd at least want like a +1 or something like that, so it doesn't cancel completely. But technically it works, so I can't hate. Are we good? Yes. Random. Yeah, could have been anything. Could have been decimals. Could have been pi. Who knows? But all we care about is that these match and not these match. It's 4 to 5 and the degrees are the same. But any degree is okay. Okay, we're going down to this one. End behavior. We're going to talk about end behavior. That's talking about x going to either infinity or negative infinity. So who'd like to talk us through how they did this one? Haley for 200.
But as divided 4x over -2 over x cubed.
And what about all this though? Like, what do you do with these guys? Why are those the only ones that matter?
Because we're talking about the end behavior. So when you're visualizing the graph, only the highest.
Are we good with that? Remember, end behavior is when x is going to infinity. So I hope you understand. Plugging in infinity and I'm missing that's something here. What number am I missing? 17. When you plug in huge numbers and then try to subtract 17 from all that, this very quickly becomes obsolete or insignificant. Same thing with the non-leading terms. They become insignificant. So yeah, for the end behavior, you just look at it 4x over 7, 4x to the 7th over 2x cubed, and then continue from there. Then we have our answer. Okay. Are we good? Could you show me that end behavior, please? Everybody, can you show me that end behavior?
It's like this.
I like that. Getting into it. Yes. Halloween style. Yeah, okay, yeah, going down this way, or the, what would have been another, like, if you were making a test, what would have been another option that would have been a cool one to put here?
2x to the fourth.
2x to the fourth, okay.
Oh.
A correct one, though.
Two x squared, or negative two x.
Negative 2x squared, would that make sense as another
Yeah.
possibility? Yeah, that negative leading coefficient and even degree, exactly. Are we good? This warm-up is forever. Okay, oh yes, Neil. Oh, negative x to the fourth, would that be okay? Oh, it's just all right. It's better than all right, that's great. Yeah, if that were an option, that'd be excellent. It's doing this. It seems like you've picked up what I'm putting down. Number 5, the end behavior. We're just talking about when x goes to infinity and negative infinity. Can you show me what's happening when x goes to infinity, please? Can you show me? Show me when x is going to infinity. Well, these become obsolete or they become negligible. So we're just left with 3x. So yeah, it's going to be going up that way. And as x goes to negative infinity, down this way. So an end behavior. So I hope you wrote limit as x goes to infinity of f of x is equal to infinity. And limit as x goes to negative infinity of f of x is equal to negative infinity, just like this does, right? That line does this. Now you may have brought in some extra concepts here. What other concepts could have been brought into this? It has an oblique asymptote. When it's top heavy by 1 degree, then it has an oblique asymptote. And you find that using either long division,
Divide.
right? Well, well, divide using long division or divide using synthetic division. Could you find the oblique asymptote, please? Yes, yeah, good.
We would write limit notation and the oblique asymptote, even if it doesn't have.
Depends what it's asking. If it just wants the oblique asymptote, then I just want the equation. If it says describe the end behavior, then I want limit notation. Yeah. Okay, did you get it? Did you get it? I'm about to call on someone. If you want to check with your neighbor, you could do that before I call on you. Okay, Chloe, can you tell us what you did? Okay. Oh, does it factor? Times x minus 1? Does that work? You have that negative 2x, but I don't know about the 1. I think you may have missed it. Oh, is it right?
Yeah.
Oh. Oh, is it 3x minus 1? Minus 1, and am I, is this a good use of my time to factor here?
I don't know. Because
Because you don't
it's
know
the
if it's
same
gonna
as the
pass.
top. Same as the mean.
You might as well just use.
So do you have another idea what we could do here aside from factoring? Yeah, we gotta divide. When you're looking for the asymptote, we gotta divide. So I'm gonna do synthetic. So in this box is gonna be 1. Outside the box is gonna be 3, negative 2, and 1. And then you just have fun.
Wait, that kind of rhyme.
You're welcome. Will you check with your neighbor to see if they know what the oblique asymptote is now that we've done this?
Yeah.
You can do regular division.
I don't.
Okay,
I don't know.
so Chloe, did you get it by any chance? Did you get the oblique asymptote? No? Okay. Connor,
That's that's one. Y equals it.
y equals 3x plus 1, and that came from? That's not gonna help on a test.
Okay.
Unless you're maths. It shouldn't.
I know like the method of how I did a long division actually. So I did.
Let's stick with what's here up here.
Realized like. It's gotta be like, okay, the twos.
Okay, just a minute, just a minute. Take the quick road. Okay, excuse me. Yeah, it's right here, guys. It's right there. 3x plus 1. Thank you. No. Asymptote, you don't care about the remainder. Because this is what the graph is approaching. That's why there is a remainder. So if we were to kind of sketch this out, we know that there is this and, oh, we'll be sketching next time, but it'll look either like this on one side, or maybe it'll look like this above it. It's going to be approaching that. Hope that makes sense. Yes, Connor? Oh, on this side, it's going to be going this way, but yeah, it still has to conform to that. So, yeah. So we don't know what's happening in the middle yet, but we're getting there. We're almost there.
That's where like zeros come in and multiplicity.
Yeah, that's today and next time. Yeah, you should be excited. Okay, new stuff. Shall we continue? You ready? Learning day 2. Last time we looked at a very special function, f of x equals 1 over x. Do you know what this function looks like?
It's our little.
Yes. You gotta do the crossover. Left hand up, right hand down. Last time we talked about, if you remember, last time we talked about this area. Specifically, limit as x goes to infinity. And this. This time we're going to talk about this behavior here. Could you discuss with your neighbor, why does it go up so high? Why does it go down so low?
Okay, basically, zero. So it's like you're multiplying.
You're dividing, 1 by, essentially multiplying by like 1,000. It's not the smaller number.
Okay. Who'd like to explain to us, why does it do what it does? Someone who hasn't spoken, I guess, was this August. Okay, but why is there vertical asymptote? What makes it? X can't equal 0. And we can see that here, right?
Yeah.
You would never divide by 0. That might end the world. Okay, so thank you. So we know that there's a problem with 0, but why does it go up so high? Why? Yeah, Miley? So the last part said x becomes smaller, the output becomes bigger. Is that smaller? Could you give us an example? So 0.1, like right here, 0.1. Yeah, if you plug that into this function, you're left with 10, right? And if you get even closer, right, you're talking about small numbers, closer than 0.1, 0.001, you start, like, how big could these y values get? Infinitely large, and that's what's happening there. The closer we get to 0, the higher those y values get. Of course, on the other side, the same thing's happening except.
Negative.
Yeah, you're putting little tiny negative numbers, so. One divided by a tiny negative number is gonna be a huge negative number. So we need to talk about some notation. You already know what it means if approaches infinity. That means x is going that way. Right? You already know when x goes to negative infinity means
That one.
that way. Would you explain or discuss with your neighbor, what would it mean if I said that x is going to 5? Just check with your neighbor, what does this mean if x is going to 5?
That's like 5 and 5. Well, then that would mean that there would be.
Okay, so x approaching 5 means what?
Or no.
You're never actually going to touch 5, right? Approaching is different from becoming 5. Do we agree with that? So if I say that x is approaching 5, what kind of numbers are we talking about? Big numbers?
Oh, very, like,
What's that, Shiv? Does that make sense? 4.999? And we could get even closer. I like that song. And we could even get closer, couldn't we? But not only can we get closer on that side, we could also 5.00000, like as many zeros as you want. So we're going to be talking today about approaching numbers coming from left and from the right. So I'm going to start this by just giving you some notation here, describing this vertical asymptote or the graph around the vertical asymptote. So I'll say the limit as x approaches, the only interesting place here is at 0. And I'm going to denote that I come from the right by putting a little plus sign there. So this specifically is talking about right here. Let me get away some of this clutter. And this limit is equal to, do you see what it is?
0.
Well, the x's are going to 0, but the function is going to infinity, isn't it?
Oh, the plus sign means like that it's from the positive side or the right side, yeah.
Right, so as we plug in numbers close to 0 from the right side, as we get closer to 0, y values are going to infinity. Yes, Matt?
Could you be writing it as plus or minus infinity?
Well,
You can go positive infinity.
let's do them separately first and see if we can combine them.
Oh.
Yeah, so this is the, you would be this limit as x approaches 0 from the left. And in this case, do you know what that limit's equal to? Negative infinity, and we can see that on the graph. So anytime you're describing the graph around a vertical asymptote, this is what I'm going to want to see. X goes to 0 from the right. That's how you would say it, where x approaches 0 from the right. And the other one, of course, is from the left. Any question? Perhaps your question is, can we have some practice? In which case the answer is yes. You may, page 12. Yes. And you could just discuss this with your neighbor, think about it, then discuss.
All right, so this one is I think so. This one, the denominator. Either this one is this one is that. Yeah. We did the whole page.
The whole page, the whole thing.
Okay, so stop. No, stop.
Yeah, that'll be.
I am the most. Nice to be equations. So you have to find which.
Okay, so third. You should move it. So that's the same thing. Negative, right, A, negative, oh, there should be letter, negative. And more of that. So the third, we have to negative.
Yeah. I mean, A, we come.
Yes.
Same with. How much it would log in, not that I use it for. One over X being four. One over X is four.
You should be constantly checking with your neighbor, especially after you finish the first three. If they have like.
Yeah.
What do you think for A?
One.
Wait. One. And I think it's one. Really, I swear, you're not adding. You're not matching. Wait, I got this. But now there's something.
How does it do?
Without one, and then we're.
I think that I read it. Yeah. That I didn't think I did. Make it like. They basically built it out.
Also.
I'll be back. No, I didn't. I genuinely was with his grabs. Yes. No. We have this iPad, we can make it results. Yeah. Yeah. Great, base, that has to be. That guy.
Oh, no.
You get one, you get. Wait. Oh, I guess we put it back. Bro, you got the last one wrong. Put that. Ian. Twice. I'll just give it beat up, man.
Is that really? Yeah, so it's all. You just know.
They all have.
That you wanna work for free.
You know what they're doing?
Yeah, I know. Wait, I don't know.
Oh, I got it. Or minus X.
But I feel like.
Alright, I feel like you crack down on this, but you just have to like. But.
Yeah.
What do you have for A's?
Yeah, but.
I thought you don't mind.
So that means the horizontal.
And then.
You finish up your thought.
Oh, yeah.
Okay, folks. Finish or not, let's go over it. Sunny day, everyone's attention. I do want to hear, just for the first example, I'd like to hear one person's point of view. Like, how did you do A, B, and C? Una, can you give us some insight into how you did this? And what your answers are, of course. Okay. Okay.
And I did the same thing for other two, I said for B, I said two, and for C, I had one.
Okay, thank you. Was there any other thought you'd like to share with us about this or? Okay, yeah, plugging in points will work and just checking to see which one corresponds. Who'd like to discuss what they thought, like just a different way to think about this? Nathan, you have some?
Find part total asymptote. For example, like, but for B and C, it's like the denominator is all different. Like, where was x plus 3, like I decided to look for the vertical asymptote times 3.
Did anyone else do this? Check the vertical asymptotes. Yeah, I think that's enough to differentiate. It's not like any of them are repeat
Yeah.
or anything like that. And then if there were, maybe we'd have to look at some points, but thank you. Una, does that make sense? And Nathan, it makes sense what she did. And it's important to listen to one another. Any other thoughts about where these came from? Yeah, Max?
I did the same thing, but I just went like straight to it. I saw like that in B, the denominator had the number 3 in it, so I assumed 2 was the answer because it's the only one that shifts over by like 3.
Ah,
C has the denominator of has the number 1 in it, so I assumed it just had to move over by 1 in graph 1, and then I just like process of elimination 3 has to do with it.
oh, nice. Okay. Did anyone else do transformations? Did you think about it like that? Because you know what the parent function is, don't you? It looks like this. And the 2 points I care about are 1, 1 and -1, -1. So in that context, this point makes sense as what? How does that make sense? In terms of this corresponding to A. Well, it was down here, right? The parents would be right there. How did it get way up to 6? What kind of stretch? Vertical stretch by a factor of 6. So that point just kind of, it's stretched up there and the other one was brought down. So great ways to look at it. Thank you for sharing. Any other ways? I think that covers it. For something like this, plugging in like 0.1, 0.001, not a great idea. There are other telltale signs, so I'm glad you didn't do that. I just want to hear about how this person did A and B. I just want A and B. This person doesn't like speaking in front of everyone, but I'm going to call him anyway. Max?
Oh my god. Okay, so.
Tell us how you did these.
Okay, well, I actually did it a very different way.
Oh,
I realized.
different.
that-
You're the first.
Yeah, we have 8 equations with 4 graphs.
Oh, so you approached it. Okay, I see.
I like looked for the ones that were like literally the exact same so that I could like just get it easier and like only have to put in one of the graphs to match one of the 4 graphs. Or one of
Okay.
the equations to match one of the 4 graphs. So I paired A with C because I realized like if you just simplify A out, it's the same as C. And then I paired D with F. And then I also realized that by simplifying B of X out. And then for A, I got the first graph because I realized that it's gonna be 4 over X minus 1, so we have to shift down 1, and it's the only graph that shifts down 1. And then for B,
So C is so wait, I'm sorry, so you did A, is that right?
yeah,
Okay, so you said so those are both 1, is that right?
Yeah.
Are we good with that, everyone? Do you see what he's saying? Okay.
and for B of X, I realized that that one is the only one that shifts up 1, because if you do X over X plus 4 over X, you get 4 over X plus 1. So I realized that was 4.
Okay. Thank you. So and that's for both of these.
Yeah.
Nice. And that's really good. So we actually got 4 for the price of 2. And I like how you tie those together. One thing I like to talk about is this process that you used here. I call it pulling a Moses in a literal sense. Yeah, does it make sense? Pulling a Moses, like if you don't know, Moses, he took the Red Sea and parted it. So we do that to this 4 of X minus X over X. And we could do that as long as you keep the denominator. But then you can see very quickly it goes right to it. Yeah, fantastic. Thank you. Who'd like to finish this off? Yeah, Jonas.
I kind of did it, slightly different also trying to take them in a way that's complete, I just like found the denominator by taking the leading coefficient of the top and the bottom and just finding like the, what it, like dividing that in the final. And you get 4x over x, and and then that just comes out to 4, and so therefore the horizontal asymptote is 4, and then that's going to be 6, so.
Anyone else think about it like that? Right, it's not middle heavy, it's equal. So you just look at the ratio of those leading coefficients. Very nice. Do you want to continue from there?
And it's kind of always been 40 in a way, so we can only find out that.
Any other, oh, thank you, that's good. Any other input someone like to share with us? I think we covered all the basics. Let's go over a couple more examples. I'm about to go off the grid here. You're gonna need your old paper for this. This is not in the packet, so I hope you do have your own paper. Yes. Okay. Yeah,
That's one way to do it. But also we could see right here, that's a shift down. Does that help? Yeah, Miley? Thank you. Okay, and as promised, just a couple of problems. I'm gonna give you a function here. I want you to tell me what you know about it. Actually, after you write it down, discuss with your neighbor. What do you know about this?
It's middle end. Because of the, yeah.
So again, you're discussing. After you write it down, you're discussing. What do you know about it?
yeah. What do you know about this function? Okay, folks. I just want to know what you got. Haley. I'm not gonna ask you why because I know what you're gonna say. I don't want to hear it. Are you good with that? 5/2, y equals 5/2. Can you show me what that looks like for the end behavior? If the horizontal asymptote is 5/2, what does that look like? What does that look like? Some of the NBA then. Is we're talking about as x goes to infinity at this side, and so it's a negative infinity. So if it has a horizontal asymptote at 5/2, that means it looks like nice one. Isn't it? It's not going up. That would be going to infinity. It's well, if you don't want to hurt somebody, you could do this. Right, that's a horizontal asymptote. That's what it is. Okay, so we got that. So thank you very much. Did you want to say anything else that you found out about this? So x equals -2 and x equals 1. Are we good with that? Very nice. Yeah, so you notice that that's just when the denominators would be equal to 0. That's where you find the vertical asymptotes. Okay, do we know anything else about this? Oh, did you find anything else? Because this is kind of the zeros. And another way to say zeros is x-intercepts. Max was doing a tactic called misdirection, so he found and followed him. Very smart. Okay. Okay, we get 3 and 4. Okay, do we know anything else about this? Yeah? He said it. He said it. And therefore, why do we care if it's that thing you said? Yeah, why do we care? So you could find the horizontal asymptotes. We already have. But yeah, it's because it's balanced, equal of that degree that we have horizontal asymptote. That's fine. Yeah, so nice. Oh, good question. Yeah, zeros in a fraction are just when the numerator equals 0. So we just set that top equal to 0. Should I multiply that out? No, what property do I use to find the answer? ZPP, just so x equals 3 and 4. Okay, so let's get a sense of what this looks like, though. I'm going to do this by using the boundary algorithm. So what are my boundaries, though? -2 and 1. And both of those, I'm actually going to draw a little vertical asymptote. Any other boundaries? The middle is not a boundary, but there are 2 more boundaries. 0, yeah, 3 and 4. But where the function equal to 0, those are boundaries. That's where it may be crossing the axis or like touching it. Does it touch here, or does it cross through at 3 and 4? Crosses through. We know that because it has multiplicity of 1. And that's the same with the asymptotes. So there's no multiplicity of 2, which means all I'm going to do is going to find one interval. Is it positive or negative? Which interval should I use? That one, yes, you got it. What's it? The furthest? If you want, I'm going to find an easier one though, specifically where x is equal to 0. If I plug it 0 into here, first of all, if I find is that 0. So if I plug in 0, that's finding the what of the function? If I plug in a 0, that's finding the y-intercept. And if I plug that in, you see that we get is that a positive number or a negative number? It's negative. Negative, yeah. So does it make sense that everything in here is negative? Are we okay with that? And I got that from x equals 0. I just plugged that in and got a negative number. Since we're talking about boundaries, anything in these boundaries, it's not going to change. Remember, this has multiplicity of 1. That means over here, I don't have to plug anything in. I know already it is going to cross from negative to positive. You don't have to plug anything in. It's super nice. Between 1 and 3?
Positive.
How did you know?
Value.
Yeah, it's changing. It changes just like the polynomials. It's not crossing through. That's the change the sign. Negative to positive. And the other ones just kind of fill themselves in. And I'm going to put these points right here. I have some negatives in there, positives in here. Are we okay with that chart? Yeah, August?
Oh, sorry.
Are you asking me in front of everybody? I don't know. All I know is next class is at 1. So we have more time. If you're
August.
Okay.
I wish you good about that.
Have fun, August.
All right. August for the West.
Okay.
Season 1 of some special.
So
Find out.
stick with me, guys. The next thing I'm going to do is describe the behavior of the function around the asymptotes, which means I'm going to examine limit as x goes to. I'll start with from left to right. I'm going to start from x goes to -2, but I have to specify because it could go 2 different ways. I want to go from left to right, so I'm going to say from the left. And this is equal to, any idea?
How do you know it's infinity? It's positive. We know that the behavior around an asymptote looks like
This. They're all positive there. So this is infinity.
now we could check that analytically, but it's a
A
little
little bit of a waste of time. But I'm gonna go ahead and check it. Let's see, f of -2.0001. I'll find f of -2.001. I'm left with approximately. And go ahead and put your pencil down for a minute. What is that? I'm gonna have 5 on the top. Man, F5. Why is this orange? Oh, I put it on annotate, didn't I? Accidentally. 5 times. Oh, that's not going to erase. -2.001 minus 3 is about -5. Do you agree? And when I plug it into this one, I'm left with, I'm sorry, when I plug it into this one, -6. And on the bottom, I'm left with 2 times tiny negative. Does that make sense? Is that right? Tiny negative number? And then this one is going to be -3-ish. This tiny negative, any tiny number is going to send that whole value, just like it did in the warm-up, to either infinity or -infinity. And the smaller it gets, the more extreme the value is. The question is, it's going to be positive infinity or negative infinity? Well, negative, 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 there are 4 negatives, so it's together, positive infinity. But that was way too much analysis, but I'm just verifying that what we did here is fine. And that's why I got it. And on the other side, the limit as x goes to -2 from the right of f of x, that one is equal to -infinity, because we know they're all negative over there. Now, we don't know what's happening in between. We're not doing that yet. But let's see. We still have to investigate what's happening as x goes to 1 from the left. And that would be equal to negative, right? These are all negative in there. And then limit as x goes to 1 from the right. These are all positive. That would be positive infinity.
Yeah, 2 for each vertical asymptotes. Yay! That's just how to describe the behavior around the asymptotes. Now you could combine them. We could say plus minus
If it were the same behavior. If it's the same behavior, but. Okay, take a moment to discuss that. Well, I'll put up another problem here in just a second. Discuss any of the concepts here.
We're doing.
Yep, same thing here. Ultimately, I want the behavior of the function around the vertical asymptotes.
Let's do this together. Do we agree that the vertical asymptotes are when x equals
Four and
Or and -2, whenever the denominator is equal to 0. So yeah, so you get your x minus 4 equals 0. But yeah, the vertical asymptotes are at x equals 4 and -2. So that's going to be part of my boundary algorithm. What else goes on my boundary algorithm? Yeah, Nathan.
The zero, right?
okay? Are we good with that? Do I need to do some fancy calculations to place that? I just have to realize it's somewhere to the side, to the right of -2. If you do that, then it'll be fine. I'm gonna put my vertical asymptotes there, and at -3/2, just for my boundary, I'm gonna put a closed circle because when x equals that -3/2, we actually get a number. And now what? Let's plug in 0. What happens when you plug in 0 to this guy? Seems like it's all positive. I don't care about the number. I just care, is it positive or negative? Positive, isn't it? So anything in here is going to be positive. That's what happens inside those boundaries. How about the other side of -3/2? How do you know? Multiplicity is 1, but the other side of 4. Pardon? Because we can see now that's coming from here and then going down here. We have positive. Yeah, that's just a boundary, the zeros. On the other side of 4, we get positive because that 4 has a multiplicity of 2. Now, let's just examine this for a bit. If I were to plug in 3.999 into this versus 4.0001, it's the same thing, isn't it? So the sign doesn't change on either side when the multiplicity is even. Yeah. So we already know it's going to be plus and then plus. Bless you. I know I get excited when I find out cool things about math too, and sneeze. -2 on the other side of that. All positive. Okay, so now we have our limit statements. Well, I'll give you a moment to write the limit statements. Yeah, Haley. It could cross through. Yeah, horizontal asymptotes can be intersect.
Right.
Yeah. But I really love how you were thinking about that. We're gonna talk about that more next time. You have a quiz coming up? Next class. Oh, exciting. Um, two this week, two next week. Yeah, it's just yeah. Let's just be Saturday. Oh no, it's homecoming. So you're writing the 4 limit statements. Make sure your neighbor is getting them correct. Yep, I want 4 of them. Because I just want 4. It's only around the asymptotes. Do you want to check with your neighbor? You see, I think everyone still has a partner as you too. We still have partners situation. Okay, we are just out of time, almost out of time. Let's start with that -2. Positive. Are we good with that? Are we good with this? X approaching -2 from the left is positive infinity. X approaching -2 from the right, negative infinity. And that's what the whole boundary algorithm is for. See where it's going. The next one is X is approaching 4 from the left. That's equal to infinity. And the other one, 4 from the right. Also positive infinity. No, I messed up there. So you could start piecing this together, right? This would look something like this. Oh, it would actually, we know where it crosses through, don't we? Crosses through there, and then comes down there this way. Excellent. We'll graph for next time. Have fun at homecoming, and I'll see you next week. Thank you. And send corrections for you next Thursday. Next Friday. Yeah. Great job, folks. I can be there?
I think so, yeah.
All right.
Connor, go to be there.
You too.